Hi students, good morning everyone. Now we are going to talk about solid state. Contents, introduction, types of solids, crystal structures and elements of symmetry. This is gas molecules, liquid molecules pictures. This is solid molecules. What are the difference? Solid molecules are closer than, so light closer. This is looser than. What is solid? Different shape, definite volume, high incompressible, rigid, constituent particle held closely by strong intermolecular forces and fixed position of constituents. What is the crystalline solids? Two types of solids. First one crystalline solids and another one amorphous solids. What is the crystalline solids? The building constituents arrange themselves in regular manner throughout the entire three-dimensional network. Existence of crystalline lattice. A crystalline lattice is a solid figure which has a definite geometrical shape with flat faces and sharp edges. Incompressible orderly arranged units. Definite sharp melting point and anisotropy and definite geometry and give X-ray diffraction bands and example NaCl, CSCl, KCl and etc. What is the amorphous solids? Derived from Greek word amorphe meaning shapeless. No regular but haphazard arrangement of atoms or molecules. Also considered as non-crystalline solids or supercooled liquids. No sharp melting points, isotropic in nature, no definite geometric shape, do not give X-ray diffraction bands. Example glass upper plastics. Types of crystal structures. Four types. First one ionic crystals, covalent crystals, and molecular crystals and metallic crystals. What is the ionic crystals? Lattice points are occupied by positive and negative ions. And ionic crystals, hard and brittle solids. Ionic crystals, high melting point due to very strong electrostatic forces of attraction. Poor conductors of electricity in solid state but good in motion state. Packing of spheres depends upon presence of charged species present. Difference in the size of anions and cations. Two types, AB types and AB2 types. What is the covalent crystals? Lattice points are occupied by neutral atoms. Atoms are held together by covalent bonds. Hard solids, high melting point, poor conductors of electricity. Two common examples, diamond and graphite. What is the molecular crystals? Lattice points are occupied by neutral molecules. The molecules are held together by van der Waals forces. Very soft solids, low melting point, poor conductors of electricity. And metallic crystals. Lattice points are occupied by positive metal ions surrounded by a sea of mobile electrons. Soft to very hard. Metals have high density strength, good conductors of electricity, malleable and ductile. Bonding electrons in metals remain delocalized over the entire crystals. High density. Law of symmetry. Three types of symmetry: plane of symmetry, center of symmetry, axis of symmetry. Elements of symmetry in cubic crystal. Rectangular planes of symmetry 3. Diagonal planes of symmetry 6. Axis of four-fold symmetry 3. Axis of three-fold symmetry 4. Axis of two-fold symmetry 6. Center of symmetry 1. But total number of symmetry elements 23 elements. First one, plane of symmetry. Rectangular plane of symmetry 1, 2, 3. Diagonal plane of symmetry 1, 2, 3, 4, 5, 6. Axis of symmetry. Four-fold axis of symmetry 1, 2, 3. And three-fold of symmetry. Three-fold axis of symmetry 1, 2, 3. Axis of center of symmetry. Two-fold axis of symmetry 6. 1, 2, 3, 4, 5, 6. Center of symmetry only 1. Types of cubic crystals. Four types of cubic crystals: simple or primitive type, and body centered or fake centered or end phase centered. First one, simple primitive type. This type is simple primitive type. Simple or primitive type, SC. Body centered cell, BCC. This is body centered. This is a simple type. Then the center point is a BCC point. Face centered cell. This is face, first one of the face, another face, third face, fourth face, front face and back face. Total 6 face of point. And end face of center, up face and down face. Number of atoms per unit cell in a cubic lattice. Simple cubic cell, 1 atom per unit cell of simple cubic. Body centered cell, 2 atoms per unit cell of BCC. Face centered cell, 4 atoms divided by unit cell of FCC. N face centered, 2 atoms per unit cell. This is simple cubic. This is simple cubic. How many points? 1, 2, 3, 4, 5, 6, 7, 8. Therefore, number of atoms per unit cell 8 points. Into what's the one? 1 cubic. 8 point each one. 8 points. 8 into 1 cubic per 8 points. 8 atoms. Therefore, 1. Body centered cubic lattice. How many points? 1, 2, 3, 4, 5, 6, 7, 8. 8 into 1 by 8 plus 1 cubic, 1 body center. Therefore, 1 divided by 1 into 1. Therefore, 2. Face center cubic lattice. How many face? 1, 2, 3, 4, 5, 6. Therefore, how many BCC? 8. 8 into 1 by 8 plus 6 into 1 by 2. Because one face attached to another unit cell. Therefore, one face attached to 2 unit cell. Therefore, 1 by 2. Therefore, total atoms 4. N face centered cubic lattice. The number of 8, 1 by 8 plus 2 up and down 2, one ended, another 1 cubic ended. Therefore, 1 divided by 1 by 2. Therefore, 2. Homework question: define crystalline solids, define amorphous solid, define molecular solids, and define metallic solids. Listen, my dear students. This is introduction of solid state. Just intro. Okay. Today's homework in chemistry, just 4 questions. Students, watch this video 2 or 3 times that you can understand the concept well. Today homework question only 4 questions. Here I give 4 questions for you, so you have to think and answer this question and these questions, and write these questions and answer 3 times in your homework note, and also write test in your chemistry strip test note and send it to my WhatsApp number. Thank you, students. God bless you.